It turns out if you compare these 7 types of EM waves, you're going to find some things are common to all those 7. They're alike in those ways. In other ways they differ, or can differ. Let's look at those ways, just make sure we understand how different types of EM waves compare. Let's see. We have here, first of all, travel at the same speed or travel at different speeds. Well, if you look at the bottom section of your MCAS formula sheet and definitions, you'll see a single velocity here for all EM waves. That says to you that all EM waves travel at the same speed. One clarification, this is in a vacuum. They can differ in speed in different mediums, but in a vacuum, they travel at the same speed. So we'll put that up here. All EM waves travel at the same speed. Next, all EM waves have the same wavelength or have different wavelengths? Well, look at your picture here. It's silly to say they have the same wavelength, right? Look at radio. That could be a mile long, the wavelength. Gamma rays, unbelievably tiny. So, EM waves differ because they all have different wavelengths, don't they? All 7 have different wavelengths. Now, the same frequency falls in the same category. It's also a silly question, isn't it? Very low frequency down here for radio waves. Very, very short frequency. High frequency up here, I'm sorry. These waves are going up and down very fast. So they definitely, all 7 types do have different frequencies. How about the next one? Same amplitude? Well, amplitude means in the transverse wave, the height of the wave. And they don't have to be different, but couldn't you have a radio wave that was very high like this and a gamma wave that was like this? Sure, you could. So I could put can have different amplitudes down here. They can be the same too, but they can be different. Finally, these are piling up down here, aren't they? Can we have one more up here? Let's see. Do all EM waves need a medium, or can they travel without a medium? Yeah, all EM waves. No EM wave needs a medium. They can all travel without. You know, an example is we always often talk about EM waves coming from the sun. We normally talk about visible light, which you can see, and say UV, which gets you a sunburn. It turns out that the sun generates all 7 kinds of waves, and they can all travel through space, the vacuum of space, and they all arrive here, all 7 of them. So the fact that they can travel through a medium, that is something that's in common with all of them, all types of EM waves. All right, let's wrap it up here by just doing kind of a summary. How all EM waves are alike. First, they travel at the same speed in a vacuum, 3 times 10 to the 8. Agreed? Next, what's the second way which is the same? They can travel through without a medium. All of them can travel, say, from the sun to the earth. They can all travel without a medium. That's the last thing they have in common, right? Now we're down to how they differ. The first is different wavelengths. Obviously, long here, short here. Before we go on, the video coded is EM waves differ. EM waves differ. That's your video code. So they differ in wavelength, obviously. They differ in frequencies. High here, low here. The last way they differ, or can differ, is in amplitude. Here we have a low amplitude EM wave, not very high, right? And we have next door to it a high amplitude EM wave. So they can differ there too. Alright, so these are the commonalities. The things are the same between all EM waves, and these are the things that differ. Bye.